Number 6 says the ages of an audience at a movie were recorded as follows, and then it lists out a bunch of ages. So we're saying we maybe went to a movie, and then we asked people, hey, how old are you? And we're trying to get a feel for, what age group is going to what movie. Is it a kids movie, an adult movie? It's kind of hard to tell just by looking at the numbers because they're all randomly mixed up. So what I want to do is organize these numbers in a way where I could get a feel for what the story is that the numbers are trying to tell me. We looked at a couple different ways. We did a dot plot earlier in the review. That's nice when you want to know every single point. We looked at histogram. That's nice when you want to look at ranges of ages. And then a box plot is also kind of another way to look at the spread of numbers as well. So what we need to do is that we first of all need to construct our box plot, and the way that we do that is that we order the numbers from least to greatest. So we want to lay these numbers out from smallest to largest, and then we want to know what is the median number, what's the middle, and then we're going to kind of break it apart from there. Looks like the smallest number, which would be 9, and next number would be 10. And then all I'm going to do is I'm just going through here and I'm listing out. Looks like I've got 11 would be 1, 2, 3. So I'm just listing out the numbers in order from smallest to largest. There's a 12. And then I've got a 13. And got one 14 right there. Got a couple 15s. 1, 2, 3. So I've got 3 15s. And looks like we got 2 16s. So 16 and 16. Looks like we got 2 17s. A 19 and a 25. And to find the middle, what I'm going to do is I'm just going to start at either end and I'm going to work towards the middle. So I'm going to mark this off as I go, and then what I'm looking for again is I'm looking for where does this thing end up in the middle. So as I'm marking off, I want to make sure that I keep track of which number I've marked off on each side. And once we get down to the middle, it looks like 15 is going to be our median. That's going to be our middle number. So what I can do is that I need to first go ahead and label my number line down here. So 9, 10, 11. Oh, running out of ink. There we go. 9, 10, 11, 12, 13, 14, 15. And I'm skipping a number, by the way, because the number line's kind of crowded. So you can do this, right? You don't have to write in every number. In this case, I'm just going to skip so that I can make sure I can write the numbers where I can read them. 16, 17, 18, 19, 20, 21, 22, 23. Oh, ink again. There we go. 24, 25, and I think that's as big as we need to go, right? Because our biggest number is 25. So it says here, describe the 5-number summary, and what we're looking for is we're looking for a couple of different parts of this these numbers that we've laid out in order. We've said that the middle number is 15. That's going to be our median. So I'm going to put a line right there indicating that that's going to be the middle. And then I'm looking for a couple other pieces of information. So I also want to know the median. If you take something and you split it in half, now I have 2 separate pieces. And then what I want to know is, well, what's the middle of those numbers? Well, I could do that by the same method of just crossing off until I get to the middle. And when I get to the middle, there's actually 2 numbers that are there, but they actually happen to be the same number. So if they're the same number, then that's what the middle would be for that. And I'm going to put a mark right there. We call this Q1 for quartile 1. Quartile, like quattro, means 4. And so what we're going to end up doing is we're going to end up splitting this up into 4 pieces. And I'll show you in a second kind of what that looks like. But so this will be our Q1, or quartile 1, which would be 11. What's our minimum? Our minimum means the smallest number, which in this case would be 9. So that's our smallest number. What's our biggest number, our maximum? Well, it looks like it's 25. And now we just want to know what would quartile 3 be. So quartile 3 is coming to this other group and finding the middle of these 2 guys. And again, I got two numbers in the middle. If the numbers are different, then you find the average of the two, or meaning, what's halfway in between 16 and 17? Well, that would be 16.5. And so what this number would represent would be our Q3, or quartile 3. So this would be 16.5. And I'm going to put a mark. That's 16, that's 17, so 16.5 would be kind of in between there. Alright, so this is why we call this thing a box plot, is that I'm going to take my median and my quartiles. So here is my quartile 1, here is my quartile 3, and then here's my median. And I'm going to make a box out of that. Now, let me go back to this idea of quartile. So again, quartile means 4, quattro. Where are these 4 pieces, you're wondering? Well, if you take a look at how we've split this thing up, right? We had one long string of numbers, then we found the middle, which broke it off into 2 pieces, right? So our 2 pieces were, that's one piece, and then that was the second piece. And then we took those pieces and broke them in half. So what you end up with having here is you end up having really kind of 4 different sections. The first section would be these numbers, so that would be the first section. That would be your second, your third, and then your fourth, right? So those are really where we get this idea of a quartile, breaking it up into 4 sections. And this is also referred to as a box and whisker plot. The whisker refers to then stretching out to what's the smallest point, and then what's the largest point, and which in this case would be 25. So this is a visual that says, okay, so it looks like the median age was 15. Each box represents 25% of the data, right? Because percentage is out of 100. 100 divided by 4 is 25. So what this represents is that this represents 25% of the people. This represents 25%, 25%, and then 25%. So the box, we refer to the box as the middle 50. Because this, and I'll kind of come to the diagram over here, right? So each one of these, that represents 25%, 25%, 25, and 25. So this whole chunk right here, we refer to as the middle 50. It represents 50% of the people, or whatever your data point is, but. And so in this case, we're saying that 50% of the people at the concert were in between the ages of 11 and 16.5. So I can come down to here, and it says 50% of the people at the concert were between the ages of 11 and 16.5. It asks me about an outlier, part B does. And so you remember an outlier is a data point that lies outside of the group, or where most of the data points are. So again, these are ages of people at a concert. Looks like most everyone's a teenager. I mean, we've got some 9, 10, 11-year-olds, 12-year-olds. But most everybody looks like they're a teenager, and then you get this 25-year-old. Maybe they don't quite fit with the rest of the group there. So to test to see if this is an outlier or not, what we're going to do is we're actually going to put the information into our calculator. So let me clear this away here. And what I'm going to do is that, let's go back to stat. Let's go to edit. If you got some numbers in there, again, L1, go down, clear it out. And then we're going to just type in the numbers. Again, it doesn't matter the order you use, if you use the original order or our numbers where we put them in order. I'll probably just go off of where we put them in order. So we got 9, 10, 11. And we're going to end up doing something a little bit different here. So we're not going to be looking for the average or standard deviation or anything like that, because we're doing a little bit of a slightly different analysis here. We drew this box plot by hand, and what we're going to have the calculator do is draw the box plot as well, and we're going to kind of check our answer, and then we're going to check on this question of an outlier. So I've got 3 15s, we got 2 16s, 2 17s, a 19, and a 25. Remember, there were 17 people that we surveyed, so we should have a total of 17 numbers, which we do. So what we're going to do a little bit differently here, instead of going to stat and then calc, what we're going to do is we're going to go to stat plot, which is above the y equals there, because we want to see the picture. We drew the picture by hand, but we want to confirm that with a calculator. So what we're going to do is you're going to hit second and then stat plot, and then we're going to hit enter to kind of go into this menu. By default, it may be turned off. So what we see how it's flashing on the on, we want to hit enter and turn it on. If yours is already darkened out on the on, great, just leave it there. There's a couple different kinds of graphs we can do. The one we're looking for is actually this one that looks like what we've drawn, which is the box and whisker. You notice the two dots on the outside of it? That says, hey, show me the outliers if there's any. Because we're kind of wondering if you know, our 25-year-old is maybe an outlier, maybe even the 19-year-old, we're not sure. So we just want to verify that by taking a look at it. So from there, looks like we got, we'll need to hit enter to make sure that that's darkened out. And anytime we want to do a statistical graph, we have to do zoom, and then we have to do 9 for zoom stat to tell the calculator that we want a statistical graph. And there shouldn't be, let me take that line out of there. That was from something else. All right, let's come back to the graph. So there's our box plot. And so what we can do is we could hit trace, and minimum, which is 9. Okay, that's what we said. The Q1, which is 11. That's what we got. Median of 15. Yep, that's what we said. 16.5 for the Q3. And then notice what they did is that our box plot actually ended at 25. But what they did is they actually ended their box plot at 19. So what we did here is we threw out the outliers. We've already kind of looked at on this test is that including outliers in your analysis can throw off your numbers. So we want to, if there is an outlier, we want to recognize it. So in this case, there are outliers. 25 is an outlier because it is far away from the ages of everyone else at the movie. Right, because again, we said most everybody at the movie here is a teenager, 9, 10, 11-year-old, and then we got this 25-year-old, right? So they don't, their age, they don't really fit with the group, right? That doesn't mean it's anything bad. Maybe it's mom, dad, cousin, brother, whoever, I don't know. But the point is that within the data set is that that number falls outside of the range of where most of the other numbers are. All right, so let's go ahead and stop here and then try number 6 on the right side.